We are starting chapter 6, unit 6, and we're going to be converting our unit circle to radians at this point. So I'm going to go through, of course, how to find the unit circle in radians, how to fill it out. I'm sure just like last time we did the unit circle, many of you will just try to memorize it. I don't have it memorized, so I have to go through the steps every time to figure it out. So first thing is, what is a radian? And a radian is the measure of the central angle whose length along the circle is 1 radius long. So using that, we think about the circumference of a circle is 2 pi r, and in our unit circle, the radius is 1. So 2 pi times 1 is 2 pi. So one way around the circle, like 360 degrees like we're used to, is the same as 2 pi. So then when I talk about the conversion between radians and degrees, you will notice that then 1 pi, like if I divided these both by 2, oops, put this back center, if I divided these both by 2, then 1 pi would be 180. And this is what I use to make conversions. So like 360 is 2 pi, 180, then halfway around the circle is 1 pi, and then 90 is half of that, which we call pi over 2. So we will use this, and we'll use this fact a lot, that 180 and pi are equal to each other to make conversions between radians and degrees. So how do you know when you're looking at like a homework assignment or a test or a quiz? Degrees will have the symbol that looks like degrees, and it always will. So you'll see that little symbol. Radians won't. So even if you see like 3 and there's no symbol, that's 3 radians, or it will say radians as opposed to 3 degrees. And so make sure, I know some of us have used Desmos. Desmos has the radians and degrees, and it defaults to radians, and I've been changing it a lot to degrees. So just know that Desmos, to check which mode you're in your calculator before you get too far with your radians and degrees if you're using your calculator. So we're going to talk about the unit circle in terms of radians. So we already kind of talked about some of the pieces. This is 0. It's also 2 pi. I know that it has a degree symbol on there. Pretend that's not there. So halfway around 180 is the same as pi. And so I'm going to think about this. So here's 1 pi is right here. So this is half a pi. So instead of saying half a pi, we say pi over 2. And then if we were counting, so like this would be 1/2 pi and 2/2 pi, like 2 pi over 2. It's the same as pi over 2. So down here we have 3/2 pi. So 3 pi over 2. And then over here, 4 pi over 2. It's the same as 2 pi over 2. So we're going to kind of keep cutting this into fractions, and each time along the way we'll cut it into a different fraction and kind of count our way through. So that's the way I do it. So we already did like the 90s, if you will. So I'm going to put those in. We already had them. We did 2 pi or 0, pi over 2, pi, and 3 pi over 2. Okay, so I'm going to do the 45. So if this is half of a pi, this quarter here is half a pi, then midway between these two is half of a half, which is pi over 4. So at this point, I'm going to start counting by pi over 4. Every 45 degrees is another pi over 4. So I've got 1 pi over 4. This is the same as 2 pi over 4, like 2/4 times pi. This next one then is, oops, draw my line funny, 3 pi over 4. And then I get here and I'm at 4 pi over 4, which is the same as 1 pi. Keeping going, I have 5 pi over 4, 6 pi over 4, which is the same, and then 7 pi over 4, all the way to 8 pi over 4, which is the same as 2 pi. And I'm gonna do the 30s now, kind of knowing what we know. And it's kind of like the 30s and the 60s all in one, because I'm going to break this then up into, notice I broke it up into 3 pieces. So if I had if I had a half and I broke it up into 3 pieces, so 1/2 divided by 3 would give me 1/6 would be each piece. So when I think about like the 30-degree angle, that's 1/6 of my pi being half of it, right? 1/6. So then this one here would be 2/6, which we are going to call pi over 3, or 1/3 pi. Here will be 3/6 pi, which is the same as pi over 2, 3/6. So then this one is 4/6 pi, which is the same as 2 pi over 3. So these fractions, we're just counting by fractions here. And then this will be 5/6. Oops, 5 pi over 6. Kind of made that one messy. 5 pi over 6 is that one, so 5/6 pi. And then you're at 6/6. So as we go along, 5 pi over 6. This is 6 pi over 6, which we know is also just pi. So then the next one is 7 pi over 6. And then we have 8 pi over 6, which is the same as 4 pi over 3. Here we have 9 pi over 6, and we can reduce that to 3 pi over 2. We already knew that one. 10 pi over 6, which is going to be 5 pi over 3 when I reduce it. And then, what was I? 11 pi over 6. And then 12 pi over 6, which is 2 pi. So they follow a nice little pattern. And you don't have to worry too much about memorize them, because if you memorize the fourths and the sixths, you could count them all the way through. So how about things that aren't on the unit circle? Converting radians to degrees and degrees to radians. And apparently when I did this, some of my lines didn't come all the way through. So what I like to think about is I want to get rid of the pi. So I'm going to put pi on the bottom and 180 on the top. So radians to degrees, you're going to use 180 over pi. And remember, we're going back to that where 180 is pi. And what happens then when you multiply by these cancel. So then I have 3 times 180 over 2. And now you guys will freak out. I need my calculator, I need my calculator. You don't necessarily need your calculator. Because 2 and 180, you can reduce that to 90. So 3 times 90. So a lot of times these can be done in your head, even though you don't think that they can. Some of them can't be. Degrees to radians, I always think I want pi in my answer. So I'm going to multiply by pi over 180. So then how would you do this one? That looks like the word 2 and not a pi, but I promise it's a pi. Well, you could break this down into its prime factors is kind of what you should be doing. So 135, I can divide that by 5, and that's 5 times 27, and then 27 is 3 times 9. So I'm going to change that to 3 times 9. So if I had 5 times 3 times 9, I'd have 135, of course, times pi. And 180, this is 18 times 10. That's an easy one. Well, 18 is 2 times 9, and 10 is 2 times 5. So why would I make you do something as ridiculous as this? Well, the 9s can cancel, and so can the 5s. And then I'm ended up with 3 pi over, and 2 times 2 is 4. So I can easily reduce this if I can break something into its prime factors. I know that 9 is not prime, but I knew that they both had a 9 in them, so I left them. If I could break those down into 3s and cancel them as well. This is kind of the biggest deal, though, making sure you know which one you want to use, 180 over pi or pi over 180. And I usually ask myself, do I want to keep pi? Do I want to get pi or get rid of pi to choose which way to go? So this says using our new unit circle to answer. I'll draw my line here that didn't show up. So 4 pi over 3. So if I'm looking at this, 4 pi over 3 is past pi, because 4/3 is bigger than pi. And then I would have to go like 2/6. So I'd be right here, 4 pi over 3. And my coordinate at 4 pi over 3 would be negative 1/2 negative square root of 3 over 2. So to find cosine of 4 pi over 3 using my unit circle, I would have -1/2. To find like 25 pi over 6, for example, you should first notice that this 25 pi over 6 is bigger than 2 pi. And that's important. So 2 pi would be 12 pi over 6. And it's more than that. It would be another one, right? Another 12 pi over 6. So now I'm at 24 pi over 6. And I need to get to 25. So this would be 25 pi over 6. I keep forgetting to write my 5. What's important here is that we kind of just found the reference angle, because I can get rid of these two, and I know now that my reference angle is this pi over 6 in here, and my coordinate is square root of 3 over 2, comma 1/2. So kind of like, you have to be comfortable with fractions. You have to be comfortable with counting in fractions to be able to do this. So now I need to find tangent, and a lot of us struggled with tangent. Tangent is y, and then you're going to flip the other one and multiply. So now I have this. This is not an okay answer. You need to rationalize the denominator, and you get this as your answer. I have a lot of examples, but I think I'm going to skip most of them because I think you guys get it. Some of yours will ask you to find the 6 trig ratios. Remember, that's sine, cosine, tangent, and then cosecant, secant, and cotangent. So you guys can find those. I know how to do it. And then this again is just using your unit circle with radians in it. And then next will be a homework assignment. No, look, I even had more examples that I'm not going to make you do. All right, and then your homework assignment will be last.